schedule. And then after this is really just one more chapter. Now, it does involve a long chapter, which also includes 2 sections. So it's about the same size as chapter 6 with 7 sections, but we threw in 2 more sections. And then that's the end of the semester. That brings us up to the end of the semester. So anybody got any questions about all that? So take a look. This is the official review. Now, I can't vouch for whether there's multiple choice questions on here, but, you know, your practice test is the best indicator of that. So, this is just kind of unusual. Just now looking at it and noticing that there's some multiple choice stuff on there. All right. So let's just start going through this. Switch over to a good color to get some contrast. All right. All this is just saying because I don't want to give away which one it is. So it's either A or an. But remember, what are we dealing with in here? What's the title of this chapter? See? Rational expressions are those things which can be written in the form of P over Q. Technically, a fraction is a rational expression. It's just that what we're dealing with now can also have variables in it. All right, now this is important because as we saw in section 7.1 and last time, that it is possible. You have to be able to identify any values that make the denominator 0, okay? Because if we have a 0 in the denominator, it's an undefined expression, and any solution that's worked out that makes that denominator 0 and the expression undefined would have to be thrown out. So the process of writing a rational expression in lowest terms is called, well, it's the title right there. See that word? Simplifying. All right. Yeah, and it's important to be able to recognize the reciprocals, because anything that's a fraction, anything that's a whole number will also have a reciprocal. But here, 2x over 7 and 7 over 2x are called reciprocals. If you multiply those times one another, it's 1. We looked at that several times with in context of different situations. We looked at it in chapter 2. We also dealt with it in chapter, what was it? 3, when we were talking about perpendicular lines. You have a negative reciprocal slope that's a perpendicular. The blank of a list of rational expressions is a polynomial of least degree whose factors include all factors of denominators in the list. Well, that's what we're doing in 7.3/4. Oh, it was 7.1. We had 7.5. I was down here in 10, but it's still the same word. So LCD, what we have to do in 7.4, we have to find the least common denominator. And then in 7.5, we also looked at least common denominators, because when we multiply a rational equation by the least common denominator, we lose all the fractions. All right, so where are we at? And this is an example of, this is what we looked at in the last section, 7.6. It's a rational expression, a rational equation, but they don't have that as a choice because it's a simple kind of rational expression. It's called a proportion. All right, that's a proportion problem. That's one you can solve like that. All right, so all right, I guess they're gonna ask us for some more stuff. So let's write out some stuff here. All right, so the first thing we got to do is all right, so if 7.3, we had adding and subtracting with common denominators already. And then in 7.4, when we have unlike denominators, we got to find a common denominator. So let's just say, I don't know how tricky they're going to be. Multiply each term by the factors necessary to get the LCD. All right. We have to write the numerators with the sign in between. So if it's an addition, you're going to put an addition there. If it's a subtraction, you're going to put this with this. That's what I mean by sign of operation. And then we use the LCD. Okay? Whatever the LCD is, we got to write everything over it. Let's see. Simplify. And then reduce. All right. Oh, you know what? This is for the down here. So let me fix this. These are rather strange questions. I guess they're good because this is for and then for this, there's less steps for the one up here. Since this one is already, since these already have the common denominator. All right, remember multiplying. All right, so the first thing we need to do is factor take out if there is any, usually when you do this and you take out the common factors, oftentimes there's not anything left to multiply, but we're going to say multiply any remaining factors, simplify. Usually when you do step 2, it takes care of 3 and 4 for the most part. Now the only thing we're going to do here for division is remember, what's the difference between multiplication and division? Division is multiplication by the reciprocal. Oops. Multiplication. And then from there on, it's all the same. That's the one difference for division. It's just multiplication by the reciprocal. All right. So, you don't want to do turn on the transcription. All right, so what we need to do for this one, this is like a 7.1 problem. Simplifying rational expressions. That's where we looked at what makes the expression undefined. All right, so again, oops, I'm not going to do that. I'm just going to write. All right, so what we do is we're going to set the denominator to 0. They didn't ask us about the steps for that. They probably should have if they asked us everything else. So we're going to set 3x minus 5 is equal to 0. And what I do, just to kind of help me keep track of what I'm doing, I just put a not equal there. Because whatever that ends up being, it means that it can't be equal to that, because it'll make that expression undefined. So plus 5. I'm still doing it just like an equation. All right, and then I'm going to divide by 3, both sides. X can't be equal to 5/3. And on this one, that's kind of a little bit tough to see, but you can see if you put it in there. Remember, that's 3/1. So that's just going to be 5 minus 5 is equal to 0. So this is what is going to make it end up fine. I guess I'll just write it here. Yeah, why do they get so many of those? Well, we might not be able to go through everything today. We'll try, but maybe 2 of these. I don't see why they got to have 3 of them. All right, so you have to factor. Everything in chapter 7 involves factoring, because that's why we learned what was in chapter 6. All right, so we're only worried about the denominator. So x squared and like I said, I usually put a not equal there just to remind me of what I'm doing. But then you just treat it just like you normally do. So we got to look at the factors of 60 that have a difference of 4. This is negative, so it's going to be a difference. So it's going to be x minus and x plus something. All right, so let's see. 15 and 4. Let's see. It's obviously not 60 and 1, because that's going to have a difference of 59. Let's see. 30 and 2 is not going to work, because that's a difference of 28. 15. Oh, I don't know what it is. So that's got a difference of 11. So here it is. It's 10 and 6. All right. And this tells us which the larger one needs to be negative. So the larger one needs to have that sign. So x can't be equal to 10. X can't be equal to negative 6. All right. Any questions about that procedure? I mean, you're just looking at the denominator, because that's the only thing that involves the being undefined. All right, same thing here. So that can't be equal to 0. And that just factors as x minus 7, x plus 7. So x minus 7 can't be equal to 0. X plus 7 can't be equal to 0. So x can't be equal to 7. X can't be equal to negative 7. And you can easily kind of see, this one was a little bit harder to see, but believe me, it would come out, because if you square 10, that's 100. And then 4 times 10, negative, so that's 40. So that would leave you with 60. 60 minus 6 is 0. Same thing with this one. This one's going to be 36 plus 36 plus 24, and that's 60. 60 minus 60. So same thing here. If you take 7 and square it, you get 49. And just the nature of squaring, it's negative 7 times negative 7, which is 49. So both of those. All right, any questions about that process? That's essentially part of the first part of 7.1. All right, so to simplify, just remember, oftentimes, like in 7.1, they had these two things kind of together. It may not be the case here on the test. I guess the best indicator is that practice test. If you go into that regular test cold without taking the practice test, you're pretty much, gonna, be surprised on what you get. Take the practice test. The score you get will generally be a good omen of how well you do on the regular test. All right, so what we got to do is we got to factor. So that's a common factor of 2 there. Here it's a common factor of x. So these would be gone, and you're just left with 2 over x. And the reason why we want to find out what's undefined, because if we've got this simplified expression, then we don't know that 3 will make it undefined, because if you're just looking at that, you have no idea. But if you look at the original expression, you can see that both x and 3 will make it undefined. So that's why this is important. And that's also why for your equations, you need to determine before you do any simplification, because once you use all your denominators by multiplying by the LCD, you are essentially not going to know what was there. You got to do it beforehand. So this one is just, again, it's a matter of factoring. All right, and down here, and remember what I mentioned in the last part of chapter 6 and also in chapter 7, you can use, like I said, this one is probably the easiest one to factor. So now what you can do is use that factored one to give you a hint on what to put here. Since this is positive, then that means they both got to be the same sign. And this is negative, so that means we're going to use the negative one. So negative 6 goes into positive 42 negative 7 times. All right, so there's the one factor, and the other factor is the x minus. Okay? Any questions about that? Like I said, that's the factoring. You don't necessarily have to go through that long process if you can use these little hints. Factor your simplest things first, and then use that, because most of these like book problems are going to be as such. that they're going to repeat the factor so that you can have something to take out. And as I said on that last one, once you got this factored, you can see, they didn't ask about this in 14 and 15, but, in 1 through 3, hopefully you can see that if x were 6, then that means then 6 would make it undefined, and also 7 would make it undefined. Because when you got this, you can't see the x minus 6 anymore, which is why it's important to be able to identify that. All right, are we good? All right, so another simplify. So again, the denominator is always, is already simplified. So again, you could use the x minus 5 as a hint on how to factor this, I'm thinking. See, negative 5 goes into 15. So let's see if x minus 5 is going to help us. All right, so negative 5 and to positive 15, that leaves us a negative 3. All right. And then x into 8x means we got to have 8x. Now, let's just see if that's right. So 8x times x is 8x squared. 8x times minus 5 is minus 40x. Negative 3 times x is negative 43x. And negative 3 times negative 5 is plus 15. And look at that. We've got our factors without having to go through. I'm sorry, this was 3. Negative 3. See if I can fix that for you. See, that was negative 3 times x. So see, there's your factors. So we're going to have x minus 5. All right. So what comes out is x minus 5. And so this thing simplified is down to 8x minus 3. All right. Any questions about that simplification or finding the what makes that expression undefined? All right. So again, that was so now we're going to do multiplication. All right. Factor each expression. Take out any factors common from the top to the bottom. Do any multiplication that's left over, and simplify if necessary. All right, what can we factor here? 3 doesn't factor. 25 doesn't factor. It would be 5 times 5. Just remember that 3 is 3 times 1, or just 3. So up here, we factor. All right, so once it's factored, take out anything common, top to bottom. It doesn't matter if it's top to bottom here, or going across, or if there was something in here top to bottom. Because if you multiplied these, you're going to end up with an expression that you can simplify, but it'll probably be harder to multiply and simplify once you've multiplied it, because you're going to be dealing with larger numbers. So what can we do here? Anything come out top to bottom? All right, nothing going that way. But notice that there's a 5 here and a 5 there, because once we took out the greatest common factor here, that was a 5 that was common. There's also x plus 8 top to bottom. And so what are we left with? This is just 1 down there. So that's just an x up there. There's no more 5. And down here, there's a 3. Notice that if you take out, and this is generally true, I can't remember there being any problems where there was much to multiply after you take out the common factors. Because if you had multiplied the original one, it would be like this. It should be x. 3 times 5 is 15, and then you got that x plus 8. Now, still going to simplify out. It's just that if you do your simplification before you multiply, it's simpler, but that still comes out. And then you're left with 5x over 15. Well, 5 goes into 15 3 times and into itself once. So you still come out with the same thing. It's just that if you kind of do it this way, oftentimes, the numbers are going to be larger. It might be harder to see your factors. But it's always wise to leave it factored if possible. With the numbers, it's not so bad. But if you happen to have, number multiplied out and it's 240, then you got to work backwards to factor it. Whereas if you take out the common factors beforehand, it makes it a little bit easier to deal with. All right, so that's multiplication there. Here's another multiplication. Again, factor, and I would suggest factoring the easy ones first, which looks to me to be this one, because that one has just got a common x. and then use what you get as a hint. Let's set up again. So this one factors as x times all right, so which one of these is factorable by 9? Well, 12 is not. 48 is not. That's like 8 times 5. There's no 9. But this one is. So this is the one I'm going to pick on, and I'm going to use an x plus 9 down there. So 9 goes into 18 twice. These are both positive, so it's positive there. And we know it's correct because 2 times 9 is 18, and 2 plus 9 is 11. Now, what do you think is going to happen? Oops, you know what? I messed up. Let me rewrite it. All right, let's see how to fix this. This is right. I get you to be on the numerator of the other one. So this is the one that should be x times x plus. All right, so let's see if we can use, we already determined that this one and this one are not factorable by 9, that last number. So the only other factor we've got is 2, x plus 2. So 2 goes into 12 6 times, and 6 plus 2 is 8. So there's the x plus 2. 2 goes into 12 6 times, and then 6 plus 2 is 8. So that's factored. And again, by going with the smallest one or the easiest one to factor, I can go through, and as I said, you don't have to go through that whole process of factoring. And that's true. Oftentimes you can do that. Sometimes if you're stuck, or if you got to do a first one and there's no easy one, then you got to go back to your chapter 6 method. All right, so we got 6. So plus 6 into negative 48, that's the only one we got left. I bet you it's going to be x plus 2, but we'll see. No, it's not going to be. It's going to be, all right. Make sure the number's right. Yeah, this is going to be, all right, so 1 is x plus 2. And as I said, 2 goes into 48, negative, I'm sorry, 6. That's a 6. Because 6 times 8 is 48. Now we just got to determine signs. The larger number is going to be negative, so that's going to be x minus 8. All right. Negative 8 times 6 is negative 48. Negative 8 plus 6 is negative 2. So we got what we need. Now we just strike everything out, and most likely there's not going to be anything left to multiply. See that? This whole thing now is 1. All that's left is x in the numerator, x minus 8 in the denominator. All right, and again, there were four values that would make this undefined. So that's a good idea to keep your mind on that. It doesn't ask for it, but just make sure you know how to do it when the time comes. All right. Any questions so far? That's multiplication. That was essentially first part of 7.2. All right, what makes this one different? What kind of a sign is that? All right, that's division. So that means that this is equal to. Now I'm just going to go ahead and write x plus 2 squared is just x plus 2 times x plus 2. That'll kind of make it a little bit easier to see what's going on. And then down here, it's just x minus 5. So with division, these both stay the same. But we got to multiply. Remember, there's no subtraction in mathematics. It's addition by the opposite side. All right. There's no division in mathematics. It's multiplication by the reciprocal. So that means that this one is going to go up here. And I'm factoring it at the same time. 2x, 2 times x is 2x, 2 times negative 4 is 4. Again, you can use this as a hint at x minus 2. Because you got x minus 2 and x plus 2. Well, that's that thing up there in the numerator. That's x minus 2, x plus 2. That's that difference of squares. All right, so what can we take out now, or what's next to do? All right. So let's just see what we got. We got x minus 2, and x minus 2. That's 2. So all we've got left is 2 All right. Nothing else to simplify, so there we go. Does that look good? So it's probably going to be another division. I'm going to give you all a few minutes. Oh, that's the answers. So since we'll probably take a little break soon, see if you can figure out how to set this up. What would this be set up as initially? You don't have to necessarily factor it. What would be the next step? Let me get some water. All right, so y'all alive out there? How can we set this up? What do we need to do in order to divide? All right, good. So I'm just going to go ahead and write it like that first. And then we'll come back and simplify. Yeah, good job on that, Christina, because that's what we got to remember. It's division, so I don't want you to take that for granted. That's not multiplication until we take the reciprocal. All right, so these three are fairly easy to, well, the 66, there's nothing to factor there. But let's kind of do it a piece at a time. Down here, that's a 6 that comes out, and you got x minus 5. So 6 times x is 6x, 6 times negative 5 is negative 30. All right, now, like I said, there's nothing really to factor up here. It's just a number, so we're probably going to have take the 6 out there if we can. And actually, there's also an 11 over here. And 6 times 11 is 66. All right. 11 times x is 11x. 11 times negative 5 is negative 55. Let's see. And then 6 times x, 6x, 6 times negative 5 is 30. All right, so let's just use some of these to help us. We only got one factor. So this is positive and that's negative, so this is good. Negative 5 into negative 5 goes, I'm sorry, negative 5 into 25 goes also negative 5. So this is a perfect square up there. Now, you don't necessarily have to take all these out at the same time. All right. So we got an x minus 5, an x minus 5, another x minus 5. And then we're equal to, the only thing left up there is just 1. So 66. And then down here, it's 11 times 6, which is 66. So what is this equal to? Now, what is that equal to if you got anything over itself? Good. All right, let's try at least this one from the break. Well, both of these we should be able to do because these are both same denominator. In other words, same denominator. So if we go back up to the procedure, so like denominators, write the expressions with the sign of operation in the numerator, and then write the LCD with the common LCD, and then simplify the new expression and reduce. So what that means is, it just means simply you got the same denominator, so we only really need to write it once. And we're just going to write all these things up there. Now, the good thing about this, and they're going to put a plus. If there were a subtraction like we're going to have down there, you got to make sure and subtract both. So it looks like 5x squared. There's only one x term. Oops, I'm sorry. It is 15x. Take that back. There's only one constant term. So negative 4 and plus 15 is negative 11x. And then there's just a minus 12 there. All right, so we could go through that long process of multiplying 5 times negative 12 and use that AC method if you want. But since we already got one of the factors, we can kind of go a little bit quicker by dividing the 3 into negative 12. That gives us the second number. And then x into 5x squared, and it tells us the other one. So what would the numerator factor is? What would the numerator factor is? So 3 into negative 12 goes negative 4 times. X into 5x squared means it's supposed to be a bracket, a parenthesis. So x into 5x squared goes 5x times. And then so this is the other one. All right, are we finished? Is there anything else we can do? Yeah, take these two common ones out. I know what you mean about canceling. You just got to be kind of careful, because essentially what you're doing is you're taking out a common factor, which means it's equal to 1. The reason why, and I know probably most teachers say this because I've heard you and my colleagues, that x plus 3 over x plus 3, they don't necessarily cancel out. If it was, you had negative 5 and plus 5, they cancel everything out and you have 0. But you have 1 there, so just realize that you know what it is you're doing, because that word cancel tends to mean that they undo one another. And in a sense they are, but you're essentially taking out a common factor of 1 when those common factors are the same. So the only thing we got left is 5x minus 4. All right, what can we do on this one? This is, again, same denominator. So we only need to write it once. So then in the numerator, I put the operation up there with this sign. See, I put the plus up there over that common denominator. And here's where you got to be careful. If it's negative, you got to negate both of them. With addition, you don't have to worry about this because you're just basically going to combine those like terms. But with a negative, you got to subtract all of those. So what I'm going to do is I'm going to apply that negative sign. Minus x is just minus x. And minus plus 3 is minus 3. So those are alike, and these are alike. So we got 4x minus x, so that's 3x. And 7 negating 3 is plus 4. Now with this, the expressions in the numerator and the denominator, or the denominator and numerator are the same. So does that look like it's finished? mean, if there were a common factor up here, we could take out, we could do that and see if anything, but there's nothing. No common factor between 3 and 4. All right, so when we come back, we'll look at the ones here with out the common denominator. Those are the longer ones. And then we'll look at some equations. And we should have enough time for that. So I'll see you in about 10 minutes, all right? If you get any questions, just shoot into the chat. Let's get back started. So no questions? No square on this thing with a test 4, right? It should be open now and going through tomorrow, I believe. And you can work on it after late, but there's a little penalty on it. That's one of the new options we got. Now, I haven't seen that before this semester, that you could put in late on a test. All right, so and just realize that next week we'll be starting the last chapter, which is not just a chapter, but it's also got 2 sections from 11. And the good thing about this, this allows you to solve some equations without having to factor, so that's a good thing. If it wasn't for especially that quadratic formula, I probably never would have gotten through algebra initially, because it took me a while to learn factoring. So everything takes time, and so you got to deal with the tools you got. All right, so let's go back to our review. All right, so here we have to figure out that there's no common denominator here. So we got to figure out on these two what the common denominator is. Now, you're also going to need to know how to do that with the equations, but let's just go back up here and look. Find the common denominator. We got to do that. Usually that means factoring them. If you factor expressions, it's easier to see the common denominator. If it's just numbers, you don't really always have to do that, but it can help. But with binomials and trinomials and all that, it's really, really necessary to factor in order to see the common denominator. And then once we get that, then we multiply each term by the missing factor, and then we essentially go up here and do this. Write the numerators over the common with the sign that's in between over the LCD, and then just simplify and reduce. All right, can anybody see what the LCD is here? Let's write it up here. It does help to factor it. The first one we cannot factor any further. What do we do there? There's a 9 is common. And 9 times x is 9x. 9 times 2 is 18. So when we factor it, it's a lot easier to see. All right, x plus 2 is common to both. So we need that factor. And what else do we need? Hint, hint, hint. What else do we need? Well, this one's got a 9, so we gotta have that in there. All right. And there was a way of putting that up here that they wrote. It says the least common denominator of a list of rational expressions is a polynomial of least degree whose factors include all factors of the denominator. All right. Now they say list here, but that just means addition or subtraction. That's the only time you need that LCD. So there's your LCD. So you need to multiply by the missing factor. This one has the x plus 2, so all it needs is the 9. This one over here has both of them, so we don't need to do anything to it. This is the way I tend to do it because I think it's easier when you have these when they show you through that formal process. Let's see, just to kind of remind you. And I had tried to show that it's really a good idea to, well, it can take some of the misery out of it. So you look at this, when they multiply 4 over 4, well, once you determine what the LCD is, then the only thing that really needs to be multiplied out of a necessity is the numerator. Because once you've got, I mean, that's automatically going to be down there once you've determined the LCD. So the only thing that's really getting multiplied is the numerator. So in a sense, you can cut out most of this mess here. Like I said, it makes it a whole lot simpler, in my opinion. All right. So the only thing that really needs to get multiplied is the 2 times the missing factor of 9, because there's no 9 over here. So that's 18 plus 3 over the LCD of 9 times x plus 2. All right, so that's 18 plus 3 is 21. Now, top to bottom, 9, there's no x plus 2 up there. So the only hope we've got for simplifying is in the numerator. I'm sorry, is the numbers. So 9 and 21 are divisible by 3. 3 goes into 9 3 times, and it goes in here 7. So that's 7 over 3 times x plus 2. Any questions? Is that good? You see anything that I did wrong or anything you don't understand? All right, so now that's it. All right, on this one, the only thing we can know what the LCD is to look at all the factors and make sure we got all those factors in our LCD. Now, what I'm going to do, again, is use that as a hint. It's already one factor by itself, so we can just look. Plus 3 goes into 9 plus 3 times. And it's going to be x plus 3. So 3 goes into 9. Both of these are positive, so it's another x plus 3. And just to show you that I'm not making this up or anything, x times x is x squared. X times 3 is 3x. 3 times x is 3x. So those two 3x's become a 6x, and 3 times 3 is 9. All right. So what is the LCD? Let's see, we're going up to 38, right? Oh, 31. All right. We should be all right on time. So what's LCD? You got an x plus 3. And what else? Yeah, x minus 3. Oh. I'm sorry, there's no x plus 3. I'm sorry, there's no x minus 3. It's another x plus 3. I was thinking the same thing. But yeah, there's no x plus minus 3 down here. So we got to take the largest one, the largest factor there. So we got to have double. So this one already has the LCD. So we don't need to fool with that one. And then this is going to be -2, that operation, times this one that this is missing. This one is missing the x plus 3 over there. And then -2 times 6 is -6. And then down here, all right, so remember, we got to apply that to everything, so that's why both of those terms are negative. -2 times x is -2x, -2 times +3 is -6. -15 minus 6 is 9, right? Plus 9. And so let's make sure I did it right. That's kind of strange, but I think that's it. So 15 minus 2 times x plus 3. 15 minus 2x minus 2 times 3 is -6. So 15 take away 6 is 9. And so there's nothing that we can simplify because there's no common factor up there. I was trying to think if maybe it was if this were a 3 there, then we could simplify, but I don't see where I made any mistake. So that must be it. All right, now here's where we got to make a decision about how to approach an equation that has rational expression, that has rational expressions in it, because all right, so in order to not have to worry about finding, in a sense, you could proceed like we did here and find an LCD and then make everything have the LCD, and then go ahead and solve the numerator, and then the denominator you could take out any common factors with it. But there's a much easier process, because if you just multiply by the LCD, and they didn't have that as one of the questions here, but in order to solve equations, if we multiply by the LCD, we can rid ourselves of any fractions. So I'm going to write that here. So multiply each term by the LCD. This will give us an equation with no fractions. All right. So if need be, you can go ahead and factor. So this one, just to rewrite it, so we can see the this is y plus 3, and this is y. All right. So this one's got y plus 3, this one's got y minus 3, so this one's got both, so that's the one we need. We got to have the one that takes into account all of the factors. All right, so we got to multiply each term by the common factors, and these are the ones that take up most of the time, this one and this one. Well, the rest of these are just the proportions. All right, so the hardest part is writing all this out. So we're going to multiply each term by the LCD, and we're guaranteed if we pick the LCD right and we multiply correctly, we will lose all of the denominators and have a much simpler equation. Now just remember that for these, we can't have x, I'm sorry, it's y cannot be equal to 3 or -3. And why? Because if you've got a -3 here, that's going to give you a 0. If you got a +3 here, it's going to give you a 0. And then either one of them will do that here. So we just need to remember, as we're moving through this, when we get to the end, that if we have a solution that's either one of those, then we're going to have to account for, we're going to have to take it into consideration and drop it. It won't be a solution. And all of those are over 1. And it's almost a shame to kind of have to go through all this just because I know what's going to come out, but in order to show you, you pretty much have to write this. All right, so let's change the color. All right. So here, the y plus 3's are gone, because remember, this is over 1. And so what we have here is 8 times y minus 3x. Over here, y minus 3's are gone, and we have -4 times y and the good news is that's the hard part over here. Both of them come out. And we're only left with 4. All right, so let's simplify a bit here. 8 times y is 8y. 8 times -3 is -24. Minus 4 times y. Minus 4 times +3 is -12. All right, so 8y minus 4y is 4y. And -24 and -12 is -36 is equal to 4. And you see that? You got an equation. We even had it up here in that step, which has no fractions, which a lot easier to work with. And so that's fine because 3 and negative 3, that was the only thing that we couldn't do. Since we're kind of first for time, I'm not going to check it. This one is pretty much the same thing. We'll skip that one because we don't have a whole lot of time. But this one is going to be factorable as x plus 7, x times x plus 6. So x plus 7 and x plus 6 would be your LCD, and you multiply. This one you would lose the x plus 7. So 1 times x plus 6. This one you would lose the x plus 7. And so you would have, the x plus 6. So it's 5 times x plus 7. And this would use both. It would just be equal to 1. All right, so let's do this last one here as far as the thing, and then hopefully we got enough time on these. So here, the LCD, there's nothing really to factor. It's just that highest power, and which is what was mentioned. All right, so everything by LCD of x squared. This is x squared over 1, so here it's just x squared times 1. And so we'll just give it right. X can't be equal to 0. Because if x is equal to 0, then this would be undefined, and so would that one. So I doubt we'll come up with x equal to 0, but so we got to keep that. So that's x squared. Here, when x goes away, and you're left with 1, so that's just a plain old x. And then this is going to both go away, and then you're equal to 42. So this is a quadratic, and that's one reason why I wanted to cover this, because unlike these two, these are pretty much the same. These would just have one solution. This one's going to have 2 solutions. So that's x plus 7 times x minus 6 so just to save time, x is equal to negative 7 x is equal to 6. Neither of which are 0, so both of these are fine. All right, let's see. We'll just do this one. I mean, this one is going to be, I'll set it up. So this is 2 times and so this would be a quadratic as well, because you got a t squared, but you'd simplify that, put everything together as quadratic. All right. So this one again, like that. So let's just go ahead and simplify. 6 times x is 6x. 6 times negative 6 is negative 36. 2 times x is 2x. And 2 times 3 is plus 6. So we're going to put those together with opposites. And put those together with opposites. This is just a plain old one, not an x squared. So 4x. And then plus 36. All right, let's make sure. All right. So 4x. So 2x subtract is 4x. 36 plus 6 is 42. All you can do is just go down to 21 over 2. All right. Now, for just checking sake, I was going to show you something that I probably should have showed you last time, but 21 over 2 is 10.5. And generally speaking, you want to keep in proper fractions, but since the checks are going to be harder when you put fractions in there, you can just check like this. So 10 minus, 10.5 minus 6. So that's 4.5 over 2. And you can't really rush with this thing because if not, it'll. So 10.5 plus 3 would be 13. Over 6. So just watch. So 4.5 divided by 2 is equal to 2.25. So they're both the same thing, so you know you got it. Probably this is going to be like written on one of the choices, but it might also accept that. I'm just saying this if in the decimal form, it might be easy to go ahead and solve and check like that. All right, we just got 2 here. These are easy to set up. The ratio of completed pass to attempted passes is, I'm going to write this like this, CP over AP. So we're going to have 3 values with one that's going to have an X in it. These proportion applications are pretty small. So 2 to 3. So that means out of 3 passes, 2 were intercepted. I'm sorry, 2 were completed, which is like 2/3. All right. So now, if you've attempted 6 passes, that's this attempted passes down there. So how do we know how many passes he completed if he's got that completion ratio? Well, three x two times 6 is 12. Divide both sides by 3. All right, so x is equal to 4. And you can see, like I said, you can check it real easy by just putting that in there. 4 divided by 6 that's 62/3, because 2 divided by 3 is also the same value. So we know that that's right. All right, last one. 4 scoops. And then this would, and that's just an S for scoops. And then this is water. All right. S. So on this, 4 scoops is needed for every 32 cups. And then they're going to give us one or the other, and we'll fill in that one and put an X in the place. How much water is needed to make the entire can of lemonade if there are 40 scoops? Oops, 40 scoops. So the bottom is the water. So 4x and then 40 times 32 is 1,280. 1,280. So divide both sides by 4. $320. So this was completed passes, and then this one was water. Well, writing the stuff out is what takes the most time. All right. All right. So, you got any questions? Stick around.